let's learn how to use a flowchart in order to assign a point group to a molecule. You may be asked to determine on an exam or a quiz to assign a point group to any of these molecules, such as the ones shown below. And there's a number of flowcharts available. They all are very similar, but in order to understand that, you have to be familiar with the symmetry elements, and so such as the axes of rotations and mirror planes, and you need to be able to distinguish between vertical and horizontal mirror planes. You need to know what an inversion center is, and of course the unforgettable improper rotation. So if you Google point group flowchart, you're gonna come across a whole bunch of different ways that these are assembled and portrayed, and your textbook may have one, but the bottom line is that they all are very similar. They're just arranged differently or have color codings, but they all follow the same idea and the same pattern. So the one that I've chosen to use is pretty simple. It comes from the textbook that I used when I was an undergrad, so it's simple for me to use. And what I've done is I have chopped it in half and put it side by side. If you look at this higher symmetry block here, I have it separated from the lower symmetry block, but essentially you start at the C infinity question mark. Okay, so you ask a question, you decide if it exists in a particular molecule or not. If yes, you go towards the side where it says yes, and you ask the next question. If it's no, you go down the other path, and you keep going until you get to the end, and then you have yourself a point group. And so, like I said, this one, if you go down to the higher symmetry block and you end up at this, are there 4 C3s in this structure? And if you answer no, you end up coming over here to the lower symmetry block. So you see I have repeated here the question for C3s. This just simply represents this entire higher symmetry block. But essentially what you do is after you answer that question, you end up here, and we'll look at that in a minute with a real example. And so this entire block really belongs below the symmetry block, but this is going to work much better as a demonstration. Okay, so let's do one example, and we will go through the flow chart with this molecule here, H2O. So number 1, the question that you should answer, is this the shape of water? What do you know? What have you learned previously about chemistry, and what can you apply to what is shown to you on paper? And this clearly isn't a linear molecule. You should know that this has a bend geometry, and because this is about symmetry, that's the first thing you've got to do. Draw it in a way that works for you, where you understand the shape so you can follow through. Alright, so this is the shape of water, and so our first question is, do we have a C infinity? That would be an infinite rotation axis, and only linear molecules have those. Water's bent, so the answer is no. And so we go down to the next one where it says Cn question mark. So we're looking for anything that is less than 360 degrees, because you do know that the 360 degree rotation is considered an identity, or it's a C1. So anything higher than that, so 2, 3, 4, 5, and that's what we're looking for. So there's a twofold axis that water has. There's just one of them. It goes right through the oxygen. And so yes, the answer is we have a C2, so N is equal to 2. Then we go over to the higher symmetry block, and so we can go through that rather quickly because we don't have C5s or C4s or C3s. We already have established our highest one is a C2, so we can go through this block rather quickly. Not only do we have not a single C4, and in order to be correct here and move on to yes, you have to have 3 C4s, so not anywhere near. So no, 4 C3s, no. And so we come down all the way to the higher symmetry, past the higher symmetry into the lower symmetry. And so here we are at this interesting, weird thing, NC2, funny symbol, Cn. Well, what does that mean? That means we have, so N is equal to 2. We've established that. So replace N here in this depiction. So do we have two C2s? This sign means perpendicular to the principal C2. So we're looking for perpendicular C2s that are perpendicular, and they would have to go through the oxygen and dissect kind of like this either, or maybe like this. So anywhere through the axes and then possibly through the oxygen. But any of those perpendicular C2s would bring those hydrogens up and out of whack. And you got to remember that your hydrogens can exchange, but it needs to be after the symmetry operation. It needs to be completely indistinguishable from the original position and molecule. So that's a definite no-no here. So we go down to the S2N, so that's your improper rotation. So we again replace N with 2, so we're looking for an S4. So an S4, so it would be a C4 followed by a horizontal mirror plane. So we can definitely outrule this already. I'd just like to elaborate that if you do have a molecule that has a C4 and a sigma H, then it definitely has S4s. If they have standalone C4s and sigma H's, or if it's an S3, you would have to have a sigma H and a C3. If you have those, then you're good to go, but you don't have to. In this case, it would be really wacko. You'd have to have a 90-degree rotation followed by a horizontal mirror, and that just doesn't work in this case. So the answer is no. We come down to, do we have a sigma H? Now that would have to be with respect to the principal axis. So somewhere here, dissecting again that C2, and that would bring those hydrogens up. So that doesn't work. And so we go down and ask ourselves the next question. We go down, do we have N sigma V's? So now we're looking for 2 sigma V's that are vertical, and we definitely have 2 vertical mirror planes here through this water molecule. So fantastic. We have arrived, we have said yes, and we have arrived at our point group. So CNV replacing N with 2, we have a C2V symmetry. And so now you can use this flowchart and assign a point group to anything. Good luck, and let me know if you need some help, and I'll make a recording for you.